All right, 4.4 properties of logs. We already know about logs, what they represent. They represent exponents. We also know what a graph looks like, and we know how to do transformations of them. But now we're going to look at the properties of logs. If you remember in the beginning, I told you kind of why logs were invented. And the reason was to make big numbers manageably smaller or microscopically small numbers manageably bigger. Okay? Logs are designed to slay big magnitude numbers. Okay? So that they make molehills out of mountains, if you will. Logs make molehills out of mountains. They cut them down to size. Now, here's the good thing. Since logs are nothing more than exponents, the properties of logs are really the properties of exponents turned on their head, like 3/2 instead of 2/3, right? The properties of logs are nothing more than the properties of exponents turned on their head. Let me show you what I mean. Here's the exponential property that everyone knows, right? X to the a times x to the b is equal to x to the a plus b. When you are multiplying and the bases are the same, they have to be exactly the same. Andrew, this is what you were bringing up. All we have to do is add the exponents, right? Okay, so look what this does. This basically takes multiplication and it turns it into what? Addition. It brings it one rung down on the operational ladder. Down here you have addition and subtraction. The next rung is multiplication and division, and the next rung is exponentiation. It brings a multiplicative property down one rung to addition. See that? And it works for division as well, right? When you're dividing, you subtract the exponents. But multiplication turns into addition. Well, here's the properties of logs that I'm going to represent using base E. These properties works for any base, legal base, greater than 1 or between 0 and 1. But I'm going to choose base E for demonstrative purposes. So here it is. The natural log of A times B, two factors, becomes the natural log of A plus the natural log of B, two terms. And notice right here what happens? Multiplication turns into what? Addition. Multiplication turns into addition. This is called expanding. When you go from left to right, it's called expanding. You're creating more terms out of factors. If you go from left to right, because it works the other way around, it's called condensing. So it's like you're playing an accordion. You can expand it. Natural log of A times B is the sum of the logs, or you can condense it. The sum of the logs is the product of the arguments. You're busy, Mackenzie. There's a few people out there. All right. Hold on. You can just set it on my desk over there. All right. Let's try it out. You ready to try it out? The natural log of 3 times 5. Well, first of all, irresistibly, what's 3 times 5? It's 15. So I could simplify it by saying that's just the natural log of 15. But I could also say 15 is 3 times 5, which now means that this is equal to the natural log of 3 plus the natural log of 5. And we don't need parentheses around the arguments here to go back to Peyton's question earlier, because it's implied that the first term after the natural log is the argument, okay? But if you want to put parentheses, you can. Okay, but I'm not going to. So another way to evaluate the natural log of 15 is to turn it into smaller pieces, 3 and 5, and evaluate those two logs separately and then add them together. This is making a molehill out of a mountain. It takes a big number, a gargantuan number like 15, and it cuts it down to size into little pieces, 3s and 5s. Got it? Got it. Okay, good. Let's try this one. The natural log of 4 times x times y. How many factors are in my argument? I have 3 factors there. When I expand it, guess how many terms I'm going to have? I'm going to have 3 terms. Let me show you what that'll look like. The natural log of 4 plus the natural log of x plus the natural log of y. Done. It's like a divide and conquer kind of thing. Would you agree? Instead of trying to eat 4xy in one big bite, one big term with 3 factors, we could break it into 3 smaller bites. The 4, the x, and the y. Take those separately and then add their results together. Pretty easy little property, huh? All right, let's try it the other direction. That's called expanding. Let's try condensing. The natural log of 4x plus the natural log of 3x plus the natural log of 2. First of all, is this expression expanded completely? No, because what could I do with the natural log of 4x? plus the natural. All right, good. If I wanted to, I could expand it further. But is that what the instructions ask me to do? No, I want to condense it. So here's what I'm going to do. I have natural log plus natural log plus natural log. So to condense it, I pull one natural log out front, and now I'm going to put parentheses. I'm putting parentheses around the argument now because I want to collect things. I want to collect the arguments here inside my new argument. So it's going to be a 4x, a 3x, and a 2. And what do I do in between those expressions? Do I multiply them or add them? I multiply them, okay? When we condense, addition becomes multiplication. And of course, now I can simplify by combining like factors. That gives me 4 times 3 times 2, which is 24x squared. And now if you want, you don't need those parentheses because 24x squared is implied to be the argument. There you go. That's what it means to condense. Sometimes we might like to condense it, like if we're not working with it. Breaking it apart into its components is very, very helpful when we're working with it. But if we have like a final product that we want to present as an answer, natural log of 24x squared is more concise. We put it all back together. Or if you're traveling on an airlines, you might want to condense it to put it back into like a smaller package so that it stows more easily in the overhead compartment. Would you agree? Good, good. All right, let's try property number 2. You already know this property because it's the property of exponents that says when you're dividing and the bases are the same, what do you do with the exponents? You subtract. So what happens? We have a division process. This is division. It becomes what? Subtraction. A division process becomes subtraction. Well, we turn that on its head and we get this. What do you think the natural log of A divided by the natural log of B is going to be? Very good. Natural log of A minus the natural log of B. Notice which one is negative? The term that's negative is the one that came from the denominator. Yeah. So the bottom factor gets the negative term because that's where the division was. The bottom factor gets the negative term. Natural log of A minus the natural log of B. Remember, the log is just the exponent. So all we're doing when we're subtracting logs is we're subtracting exponents. All right, let's try it out. The natural log of 4 thirds. 4 thirds. 4 thirds. Well, that's the natural log of 4 minus the natural log of 3. All right. We took a mountain and we made a molehill out of it. Broke it down into its components. All right. What about the natural log over 7 over 6x? Good. Natural log of 7 minus the natural log of 6x. Is that expanded completely? No. What could I do with the 6x? Those are multiplied now, aren't they? So that's what have to be added. Now you got to be careful here. When you're subtracting a quantity, I better put parentheses there, shouldn't I? I get the natural log of 6 plus the natural log of x, but that whole quantity is being subtracted, which now if I distribute the negative, it becomes the natural log of 7 minus the natural log of 6 minus the natural log of x. And you should be able to go straight from here to here. Okay? Here's all you have to do. Every factor in the denominator is a negative term. So you could just start off by saying, oh, we have 3 terms, so we know we're going to have 3 factors. 2 of the factors are in the denominator, so those 2 terms are going to be negative. So you can skip that step and go straight from here to here. In fact, I want you to be able to expand it in a single step, in one fell swoop, as I say.
Will the terms and the factors always be hand in hand?
Will they always be what?
Hand in hand. So if there's 5 terms, will there be 5 factors?
Yes. The number of terms is always the number of factors. Absolutely. That's a good way to reconcile yourself at the end. Okay? All right, let's try condensing. I have negative, negative, negative. There's 3 negative terms. So I'm going to pull a natural log out. I'm going to put parentheses because I'm collecting things. All negative terms have their arguments come from where? The top or the bottom? The bottom. So there's a 3, there's an x, and there's a 5x there. What do I do with those in the bottom? Do I subtract them, add them, or multiply them? I multiply them in the bottom. Very good. Now, what does that leave for the numerator? A 1. Very good. It's like adding plus a natural log of 1 right there. What's the natural log of 1? Nope. Natural log of 1 is 0. Okay, so you can add 0 to something, can't you, without changing its value? So you can add a natural log of 1, and now you have that placeholder for the numerator, plus the 1 in the top. Okay, so this now simplifies to 1 over, and you don't need the parentheses here anymore. I'm going to keep it, 15x squared. Because it's a fraction, I think I'll just keep them there. All right, then the last property, which is my favorite property, if you want to write this on here, Corpy's favorite. Okay, Corpy's favorite. Look what this does. Whenever you raise a power to a power, what do? You multiply. So notice what we're doing here. We're taking exponentiation and we're turning it into multiplication. Does that come down one rung on the ladder? Addition, subtraction, multiplication, division, exponentiation is the top rung, right, in PEMDAS? Yeah. Did we take it down a rung? Yeah. We took it down a rung, right? That's what logs do. They take everything one rung down lower on the ladder. So instead of exponentiation, it becomes multiplication. So look what we have here. The natural log of a raised to the bth power. Guess what I could do? I could bring the b out front as a multiplier. I like to even make the sound effect. B can come out front. Watch this. The natural log of a to the b. If you actually write it like that, you can lasso this with your lasso tool on Notability, and you can animate it. The natural log of a to the bth power is b times the natural log of a. See that? It takes exponentiation and turns it into multiplication. You can bring it out front. Now, why would I not want to bring it straight down right here? Well, if I brought it down like that, now it's confusing. Now I think the argument is a times b, right? If you want to bring it down on the other side, because multiplication is commutative, you'd have to do that, wouldn't you? So that we know b is being multiplied by the natural log of a. So that's why we typically don't do that. We typically bring it to the front. All right, let's try it out here. What's the natural log of 2 to the third? You can put it on my desk, Ryan. Well, that's the natural log of 8. But what else is it equal to? 3 times the natural log of 2. I just made a molehill out of a mountain. I took this huge number 8 and I broke it down into its small parts. Go me. All right, what about the natural log of x squared? That's 2 times the natural log of x. Not 2 but 2 times the natural log of x. Fantastico. I just slayed that problem. That's called expanding. Let's go ahead and condense. Now, when you're condensing, what you're going to notice is you do have 3 terms. They're all natural logs, but I have constant multiples in front of each of them. Where did those constant multiples come from before they landed in front? They were exponents on the argument. So when you're condensing, the first step is to bring them back up. That's the natural log of x squared plus the natural log of 3 squared minus the natural log of y to the 4th. Yes, yes? And now I can fall back on the sum or difference ones. Now I have positive log, negative log, so I can pull one log out front, build the shelf. If you ever have a negative term, you can build the shelf. What goes in the top? The x squared and the 3 squared, which is 9, yes? And what goes in the bottom? The y to the 4th. Yeah, there you go. And congratulations, we just condensed it in one fell swoop. All right, so we're not going to get to 3D. Well, actually, we can. Watch this. I can bring the 2 up as the exponent. That becomes e to the natural log of x squared. Now, what's e to the natural log of anything? They cancel out, and I'm left with what? X squared. Perfect timing! All right, we got through example 3, all 3 properties. That was my favorite. Y'all have a great day. Don't let logs